Thin layer chromatography for secondary metabolit identification. Indonesia is rich with natural products. Active compounds within the natural product believed to give health benefit for human. That's how jamu, or Indonesian traditional medicine, passed down for generations.
My name is Prof. Mai from the Departemen Farmakologi and Terapi, Faculty of Medicine, Public Health and Nursing, UGM. Today I will give a short explanation about secondary metabolite identification by using thin layer chromatography. Secondary metabolite is the group of compounds produced by organisms like plant, microorganism, animal, and marine organism. It is believed that the secondary metabolite is essential for the plant survival. Secondary metabolite can be consist by terpenoid, alkaloid, phenolic, and also flavonoid, and so on. Several methods can be used to identify the secondary metabolite such as SPLC, GC, and also thin layer chromatography. Thin layer chromatography is one of the most favorite technique in the identification and semi-quantification of the secondary metabolite. The reason was because TLC is simple, fast, cheap, and also robust. The principle of TLC was based on the separation of two or more compounds by the different distribution of the compound. In order to get good separation, we can change the stationary phase and also mobile phase profile. Several stationary phase can be used such as cellulose, silica gel GF254, silica gel P, and so on. On the other hand, the mobile phase may consist by the combination of organic solvent with proper ratio. Okay, to make it easier for you to imagine, please take a look of the following simulation.
There are several materials to search for the active compounds, such as extract materials, appropriate solvent, and standard marker for comparison or detection analysis. All the equipments needed are thin layer chromatography silica gel plate, pencil, ruler, chamber, capillary pipette or micropipette, tweezers, tissue, and hair dryer. Firstly, marks the edge of the TLC plate approximately 1 cm over the bottom side and set it as the spotting spot of the sample and the marker. Put the sample extract and standard marker into the triple plate. In case you are going to make a semi-quantitative analysis, prior to this step, weight the sample on the analytical balance. Dilute the sample with appropriate solvent. For semi-quantitative analysis, record the volume of dilution you made. Spot the sample on the TLC plate. In this step, you may use capillary pipette for qualitative analysis or use micropipette volume for semi-quantitative analysis. It is also to employ linomate when you are working with a densitometry machine. use hairdryer in order to foster the drying process of the spotting samples. But remember, do it on the back side of the TLC plate. Put the TLC plate into a saturated chamber contains proper mobile phase. In this step, many compounds within the sample extract will be separated based on its polarity difference. Once it is eluted to its maximum elution point, in other words 8 cm from the spotting area, take the TLC out of the chamber. Wait until the plate getting dried, or you may use hairdryer to faster this step. Observe under UV light in 254 and 366 nanometer wavelength or under normal light, which depends on the characteristic of the target compound. Some compounds are required to be sprayed with a specific reagent in order to boost its appearance on the TLC plate. Then, heat it in an oven for approximately 1 until 3 minutes at 110 degrees Celsius. Observe the eluted spots. Calculate the retardation factor or RF by measure the length from the spotting area, then divide it with the total length of the elution. Compare retardation factor of the targeted compound of the sample with the standard marker. That's all about thin layer chromatography for secondary metabolite identification. Thank you.